Hi, Goran. Welcome back.
Hi, Adam. Nice to see you again.
How was
Was it
the summer?
really busy summer? I don't know what people are doing these days, but I think that we have like more and more work to do. Not like moving so many applications from one platform to another, refactoring, and this thing will never end. So, like a really working summer. I don't know how to say that. How was
Yeah,
your summer?
very similar. Lots of requests, lots of Java in the clouds. So crazy summer, I would say. It was never as busy as now, but it's a good thing. So I know
Yeah.
keep it.
I've heard some people gathering at the island of Crete, for J Crete and stuff like that.
Mhm.
I was really impressed with this. I'm really impressed with this conference, but I don't know. I have to find time and energy and somehow to get somewhere during the summer to spend it in a way that I'm really relaxed and still like read something. I just can't get into
Yeah,
that
the
mode.
problem is the time. So yeah, I
Yeah.
tried also to avoid conferences if possible because of time. But what I do from time to time, if it works, a short meetup, and which usually works. Now, back to the topics, to our topic. So, one interesting topic is the persistence in the cloud
Yeah.
on AWS, for
Yeah.
instance. And it's really interesting, especially if we consider this from Java. So, how to call
Mhm.
something or how to choose the persistence on AWS. And some things are not that obvious, right? Like connection pooling, for instance, that there could
Yes.
be some challenges. So we already had the story about you. So you are the
Yeah.
MySQL fanboy.
Yes, 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 yes.
Yeah,
Exactly, exactly.
and you
That's my
like it and you
favorite.
run it in production. So which databases are you using in production currently, or which
Yeah,
persistent services, not
yeah.
necessarily databases? So
The crazy thing is like I'm always thinking about that. What is actually a database? Like, you can call anything a database if it has a storage and a proper index.
mhm.
And there's a lot of other stuff that goes into like a database management service. How is it called? But in general, anything can be a database if you have an index. Like so. Uh, the database I use mostly these days it's AWS S3.
Mhm.
When you look at the number of requests, the data I keep there, it's a storage, but with all characteristics of a database. So it's a key value store. It can keep small and large data, and the good thing is that it's also now integrated with a lot of other services. So you can save a lot of data there, and for example in JSON or other or Parquet or other formats, and then you can make a query on these data, especially if these data, if that's something that you don't really need too often, like logs, GPS collected data, IoT data, and stuff like that. So you can query them. You can make a SQL query and then get results from that storage. And from that perspective, you see when you forget about like all these years where we only thought about relational databases. Now everything is a database. So you just need an API, and if you call the API and say put or whatever, it's a database. So and in that terms, the other database that I use mostly these days, of course, is AWS Aurora, but MySQL, yeah, like flavor. Uh, but look what they did. They replaced the storage layer in the
but wait a
database
sec
with.
with the S3
Yeah.
because I also use it a
Okay.
lot, and even more interesting, I use it actually for very frequently access data. And I thought actually it won't work because of latency. But what I found out that the latency, at least in Frankfurt, is pretty good. So actually, you can
Yeah.
call
Yeah.
even for small object the standard S3 in 30 milliseconds. So this is
Yeah. Yeah. So it
you know
depends what do we call fast these days.
yeah, this is not
It's-
fast, if you compare it to DynamoDB, but it's still okay if you compare it, because you can store the entire JSON object there, and this is really what you do. And what's S3 is also interesting for, it has a kind of a folder structure which called prefix. So with that, you can
you can
if you
list.
are, you can have search on key, or at least you have a folder like structure, which is good enough. And it's not like S3 is very convenient for us Java developers because it is more like a hash map. So it's very similar to a hash map, I would
Yeah.
say. If you can actually create an abstraction for S3, which would be hash map like. But the interesting part is, you mentioned this already. One thing is very cheap, so it's the cheapest because it's the it is the foundation of everything else. So all the backups of other databases actually stored in S3, and all the persistence is usually S3. And the other stuff which is interesting, it is you get the failover always. I mean, it is always stored. I think in 6 locations, and you have it depends of course on the tier, but backup. You can have optional backup. Not to back up your data, but more like
you can copy
deletion prevention.
Else,
yeah, right. And compliance. So there are lots of stuff which is already compliant. So you don't have to legal lock. You can say I cannot change the data which is already there. So this is
and you can do SQL query. You can do SQL query. Yeah. Do you use Athena for stuff like?
If you don't not always because you have to create a schema first. It is not ad hoc, so you will have to create the schema first, and then you SQL with Athena, which is actually Presto. So you can query it, but you have to do something first, which is okay, but it's not always needed, right? So but
there's a thing called glue crawler. Okay, mm-hmm. So you can just point it to a folder and it can detect the schema.
Yeah,
and also it can change the schema. So if you add some new column in a JSON or CSV file and then upload it there, it will automatically detect the change and the data will appear in the next query. Mm-hmm. So it's you see the database system is now a complex thing. It's a lot of APIs around something. So who cares what that is? You just call the API and you store it somewhere and you can query it. You can get data from it, and if it's really secure and available all the time, then you're fine. So who cares how is it called?
Yeah, sure. I mean, what interests me as Java developer is, of course, how to access the stuff, right? Because of course, everything, if it's persistent, I mean, if it's durable, I don't care, but how to call it. And now it comes, right? The S3, the API is semi-convenient, I would say. So it's a REST API. I mean, you can just,
exactly.
call the object a story. So it's I would say a Java class with complete CRUD, create, read, update, needs about 300 lines of code or something like this, maybe a little bit less. So usually how it starts, S3 client.create, and you have it, and then you can use the API. The async API, there's an async API, and the cool story is it is even GraalVM compatible. So you can actually pick the S3 API and create a native image if you like. Yeah. So, and now it comes what's interesting. Because it's the Amazon API, it's HTTP based.
Yeah.
So
everything in cloud is HTTP these days.
Yeah. But this is one of the recurring questions I get. If you have, let's say, Quarkus, and it calls to S3, and this is a Lambda, you don't have to care about connection pooling or whatever. It just works. If I would use Postgres or MySQL, the first question is, I have 1,000 Lambdas, and every Lambda creates 10 connections. So how to deal with it? So we will need RDS proxy or something like this. But with the S3, because it's a native serverless, I would say, serverless service from Amazon, S3 should be not simple storage service rather than serverless storage service, actually. We don't have the problems with how to deal with connections, right?
Okay, so if you think about that now, like just stop for a second and see, everything is going in the direction of HTTP,
Yeah.
One day there will be no binary protocols to connect to database. Like that's really a big problem for the cloud because you open the connection and on the other side there is a process it's waiting for you. And in order to get this scalability to the level that AWS does or whatever, you need an HTTP, like a universal protocol, but it has to be improved. We still use HTTP 1.1 in most cases. Even if the front is HTTP 3 now, still, like the CDN is connecting back to the backend services through HTTP 1.1. Okay, and if you look from that from Java perspective, there is no native Java library for HTTP 3. Everyone is using Cloudflare's Rust solution and through Java. How is it called now? That protocol that to connect native stuff, binary executables. So even Netty, Jetty, whatever is using that same thing. So we don't have it in Java. So if you look at the client libraries, there's still 1.1. Okay, and that means you are stuck with a lot of issues. Like you cannot have multiple connections at the same time, and you cannot multiplex them. You cannot get the response at the same time.
But you are
one day.
Yeah.
If one day we'll have HTTP3 libraries, so we'll have a full multiplexing in both directions with no stops in between, with automatic TLS in it, and we will have support from a proxy server which lies between, so you can handle stuff. Even it doesn't matter if it's Dynamo, if it's MySQL, if it's whatever database it is now in the cloud, it requires a proxy server. Why? It's not just about like the number of connections. It's also about routing your requests, because if I ask for some data, the proxy can be smart. Amazon DynamoDB is a smart proxy, so it looks inside your request and checks for the partition it has to go. Partition is just another server somewhere, so it has to route that request to a particular server and get the response, So everything has to go in that way, so we can really enable all the services to use that one system. Okay. Otherwise, we are stuck with all these binary protocols. Sometimes they're great, and still they are great. But in general, if you want to go to the next step, we have to do that. So in Java, we are stuck in 1.1.
Yeah, but you are very technical right now.
Sorry.
No, very good.
But that's the problem. That's the problem.
But the problem is even earlier. So if you look, for instance, on Kafka, right?
Okay.
And you set up Kafka, which is also a persistent service. I would say Kafka is a database more than a message queue, right?
Exactly.
So if you set up Kafka on AWS, let's say the MSK standard, so you can use CDK, what I usually use, and 40 minutes later you have Kafka. But you have an empty Kafka, so there is no topic, nothing. So and then you have to use Kafka proprietary, Kafka API to create the topics. And then you are communicating with these topics via binary protocols, which has nothing to do with HTTP. This is Kafka on protocol. So where I'm going with it, if you would use Kinesis, which is of course not Kafka, but similar, first you don't have to provision the Kinesis stuff because it's already there.
Yeah, it's already
there. If you create a topic, you can access the topic exactly the same way and very similar way to S3. So you can say, Kinesis, and I just send to the topic an HTTP message. So where I'm going with it, if you are using HTTP APIs, all services are secured in similar way because of IAM of Amazon. Yes. But if you start to use the open source binary protocol, it is outside of of the Amazon, let's say AWS APIs. So you have two security models. You have Kafka security model and you get the Amazon security model. Yeah. If you use a Postgres or MySQL, you can use the Postgres user management. Okay, you can set up IAM authentication with the plugins, but you have to do this for the IAM authentication. So you can use IAM users to talk to a database. But if you use a DynamoDB, you just use your IAM role on IAM user and you are in. So there is no secondary user management. Everything is the same. So from the simplicity point of view, what I really like is just to going, using one protocol for all these services. And what it actually means is, mostly I'm preferring proprietary managed AWS services because I get the same access to everything. But even if I would use Kafka or MySQL, Postgres, whatever, then I have the problem. I have to use Amazon's SDKs or CDKs to provision the service. And then I have to use different APIs to use the service. So this is actually, from the conceptual point of view, very interesting. So I was talking about that on Meetup for Java developers because back then I said I don't care about clouds. I can actually run everything on premise, and it's usually cheaper. But if it doesn't work and I have to go to the cloud because I have scalability requirements, disaster recovery, security, or whatever, and I'm in the cloud, then I will switch the strategy. Instead of I'm depending on the cloud anyway. So instead of using, open source technologies, I would rather use, the cloud built-in technologies and use the features. So this is actually where I'm going.
Well, the things are getting even more complicated. Now you can have a front exposed API compatible with a binary protocol of Postgre. And then in the backend, you have the same like NoSQL, whatever database, who knows which technology is behind. So it's kind of it's a really mix of everything now, because you have developers who don't want to change their libraries or their code, but you need to scale your database. Okay, just keep the protocol and switch the database. So maybe you can use Yugabyte, for example, if you're using Postgre, you can have completely cloud stuff, and then but in reality, the thing that you just said is that if you want to go and use AWS or any other Microsoft or other clouds, well, people should get used to what's inside, what's the best thing that they offer, what's the best way to connect, what's the best because using this general protocol won't get you to these results that you can get in terms of if using proprietary local AWS stuff. But on the other side, of course, in most cases it doesn't really matter. Do I get 1 or 5 more milliseconds? It's maybe it's good to have a general solution and then use it everywhere. So, but I think the general solution is more about HTTP. Not about this binary stuff. I've been reading
it could even binary, but it has to be the binary protocol of the cloud. So for me, it's important. If you use, for instance, AWS, and I'm using the Java SDK. I actually don't care what's behind the scenes. For me, it's important that it appears on the CloudTrail, that it is secured, that I see the entire traffic. So actually, AWS could use whatever they like. So it should be a unique protocol hidden behind the SDK, because I'm usually not using curl, right? I'm not using curl to communicate.
HTTP3 is the solution, because multiplexing, no blocking, everything is there. The thing that you just mentioned about the way you can connect to Dynamo, okay, and if you are in AWS, you make a call, and there is a permission strategy, in AWS. So the thing that is good, because you have HTTP, and you have proxy between. When you make a call, the proxy can detect. Are you are you allowed to access that particular record or particular row or whatever, and it's aligned with other policies in AWS. The way you deploy it, you can deploy it via infrastructure as a code stuff. All these policies about the Dynamo.
Yeah.
And when you try to do the same thing with MySQL or Postgre inside AWS, there's no way to log that. You have to go deep inside the binary protocol and then do these changes. So there's no way to limit per row, per cell, any kind of access through proxy. That's not possible.
But the issue is less, the protocol, more that is an external product. For instance, there's Aurora V1, and there's some data API, which was interesting.
Yeah, okay.
So you could use HTTP from Java. I think it's not available yet in V2, so I'm waiting for it actually.
Yeah, it's not.
So, but if it would be available, this would be a solution. So what Amazon did, they created a proprietary HTTP-based protocol on top for Postgres. This is what I'm using mostly, and you can use the data APIs. The question is now why you would like to use it, and the answer is, of course, because security and connection pooling. This is the only problem I have. Nothing else.
It automatically includes the connection pool inside. It's the proxy. Sorry, so it's not visible to you. You don't see it, but it's there. It has to scale. All these days, everything is about connecting to the database and getting JSON out. So if you have a service that brings you JSON, you don't care about that. What's behind. In that terms, if you look at AWS, their strategy is okay. There's no one database that can rule them all. You have to use database for a specific purpose. Okay, so if you use if you have data which is organized in kind of graph, you would use something called Neptune. Okay, if you use if you have a lot of logs, or you're dealing with a time series, you would use a time series database. So it's every single thing has a database for itself. And then if you have, for example, if you write data to DynamoDB, there's no way to get kind of a group by sum or some kind of aggregation, okay, in there. So if you want to do aggregations, you have to export data from Dynamo to something else, okay. The good thing is that you can use change data capture technologies, and there is a service called database migration services that can do stuff for you automatically, or you can use Debezium or other solutions that can do that through Kafka. You can do that by yourself. But in general, if you write data to Dynamo, it can end up also as a copy in like 5 different databases, like in S3, in whatever, and then you can do the aggregation.
You can even use DynamoDB streams, which is fully integrated. So it just
that's it. It uses streams. Yeah, change data capture uses streams. So
but the change of strategy is interesting. So my question is how you see this. So what you did back then, let's say we use Oracle, let's say, and we access Oracle only through JDBC. Why? Because we said, what happens if the company changes the strategy and moves from Oracle to DB2? So this was our Java strategy for years. We didn't want it to be dependent on a product. So the entire architecture and strategy in Java was vendor neutral architecture. So you didn't want it. We have JMS not to be depending on, let's say, MQ series or whatever. What's interesting is my observation. If you go to the cloud, you can forget the strategy. Because the first thing you are absolutely depending on the authentication and authorization, and this is everywhere. So to do it right, I would spend a significant amount of time just fiddling with roles, IAM or identities on Azure. So you will have to spend some time with the security, and of course networking is also proprietary, and you will have to spend some time understanding how networking is doing. And so where I'm going with it is less important to be independent from a product perspective, because you are depending on the cloud anyway, and you can try to abstract whatever you do, but it is I don't know. You are actually the right guy to ask. So if you would migrate your entire system to Azure, I don't think you will spend a lot of time with the Docker containers and Quarkus or whatever, but you will spend a lot of time with security, load balancers and stuff which you not even think about, and you cannot just there is no open source load balancer, or there is no open source subnet or nothing. You will have to actually to deal with the infrastructure. So interesting story. Would it be actually where you would spend most time if you would have to migrate from AWS to Azure?
Okay, so the first thing is that there are two types of interacting with the database, like writing and reading. Okay, so in terms of writing, I would go with the best technology I can to provide the fastest writes, like the most secure stuff. Okay, and that would mean that I would go with the JDBC driver or whatever, like try to connect in that way, and then ignore whatever else is available. I would go with the fastest write. Okay, but in terms of read, where it can scale in a different way, I would go. What I have in all my applications, I always have a layer that translates access to the database to a JSON. So I always communicate with my API to get this data. It's a kind of almost automatic, like we can write queries, and then put it in some kind of a repository of queries and in the application, and then you can access it. So there's always kind of a JSON to database conversion. And then from that point of view, I use the same application. I don't care, from the perspective of the front end, or like all my reads, like 90% of my reads, which I used in the front end, are coming from JSON. I don't want to communicate in any meaningful way with the database from a layer that provides data to front end. Okay, so there's always JSON layer. So the good thing, like if AWS can provide that API, that's great. I can use that. There's maybe I don't know if you heard about that. There's a database called PlanetScale. Okay, it's a kind of who's familiar with the MySQL. It's a kind of a commercial product of Vitesse.
Vitesse, okay.
Okay, so they're kind of
this is your YouTube. YouTube use Vitesse, right? So
yeah. It's a MySQL sharding solution, and it's super scalable, and they just created a data API. So you can call the data API and then connect to your MySQL in the backend. So for many cases, you don't really have to know that there is a database in the backend. So who cares? So that's what I'm saying. Like you need to have a layer that translates to JSON, and then you do the rest. So my strategy would be that.
You also don't care about the particular database. It has just to work. So this is what you are saying.
And in many cases, I switch between Dynamo and MySQL. And if you do a big, in my case, we have a large database, MySQL database. And it's kind of terabytes big. But then it's a kind of legacy. You have to move some data. You have to split it. You have to make microservices. Blah blah blah. And then you can't do that in a day. It just takes years. So you cut piece by piece, and then put something in the S3, put some data in Dynamo, put some data somewhere. But from the perspective of the client application, it's always JSON. I don't care anymore. So the speed of any of these databases these days is great. So you're saying like using S3. 30 milliseconds or something. Perfect. I don't care. Like in most cases, you can store data there. You can cache data there. Like especially for those applications who are like a more read oriented. That you have like any kind of social network or anything. It's more reads than writes. And in terms of like, if you look at the case that AWS had a couple of years ago, they moved completely from Oracle to anything else. Okay, so it's mostly DynamoDB, Aurora, usually Postgre and MySQL and stuff like that. So they recognized that 90% of connections to the database were reads, and not super special reads. It's key value reads. So it's in terms of that, you have to really rethink what you're doing. Like what kind of a database we are now using to just get key value stuff. So it made no sense. But
so one question now, because now forget database and consider your entire system, what you built. So let's say you had to migrate away from AWS and to Oracle Cloud, or let's say Azure, and they have similar services. Where do you think you will spend the most time fiddling?
I was just doing something like that, because of all this war and all this uncertainty, and many companies are kind of worried about the cloud again. We just had this kind of super optimistic look at the cloud, but now kind of okay, maybe I can just run this on premise. So I'm using Quarkus to get the result, to have the same business code in the application, and then the REST API is doing stuff for the serverless Lambda in AWS, and if I build it in a Docker, I can deploy it in Kubernetes and get the REST microservice. So it doesn't really matter, So how do I get the authentication, other stuff? It depends. You can just do some kind of add some plugins and you add some kind of maybe use Keycloak or other technologies. But at the end, it all ends up in some token, JWT token, and that's it. You don't really care about that. The biggest problem is how do you simulate? How do you make the layer that can map S3 or other stuff? So that's a bit tricky. You cannot make a solution that can work for any service.
Yeah. So my observation is you can map S3, let's say, to I think it's called blob storage and web storage on Azure. But where I spend most of my time, if such projects, is authentication, authorization, the tokens, because you need to know Azure ID or Amazon Cognito, and there are different possibilities. And the next stuff is networking, because if you are public service, it's relatively easy, because public IP, you can just do it. But if you start to hide the services behind the intranet, Express Route on Azure and Direct Connect on AWS, then it becomes interesting, because, for instance, on Azure, if you would like to have, the hidden communication between your data center and Azure, you need complete different plan called premium plan, which maybe it behaves completely differently to the other one. So I would say,
is there always a premium layer in Azure? Like if you can do this, you can buy premium and then it works, or something else? How is that? Does it work?
Yeah,
in
you
Azure?
have to. Yeah, this is almost look like this. This is like the on-demand plan. I think basic and premium. It depends on the service.
Kidding.
No kidding. This is and if you have a service, let's say Fargate, how this would work. So with the on-demand plan, you get charged per request, and then with the standard plan, you get charged. You can change this is a little bit. So you get your own dedicated infrastructure, and with the premium plan, they will start. I'll assume behind the scenes Kubernetes for you, and then you can use it, and you get better networking. You get more isolated, which is not bad actually. The plans is actually you have to know about this, because if you just do a proof of concept and you have you have the pricing and everything is in internet, and you need the private networking, maybe it's not even available for a service. This is the thing, and this research takes a lot of time. But never database layer or Java or JSON, we can fix it in days, but this can take weeks until it works. So and this is what is different.
How much difference does it make? How much difference does it make for you? Like, do you get 1 millisecond extra faster application? That's why we have Kubernetes, because we decided that the speed and all these things, like a super speed, is not that important to customers. The most important thing is to deploy applications fast, to the cycle of development to be faster. Yeah. The other
I will still
stuff,
not go with Kubernetes. So what I will do is, for instance, on Amazon, I'm going with Fargate. And on Azure, I think I'm a little bit confused with the names because Azure introduced another thing called Azure Container Apps, I think, and there's Azure App Services, and they are very similar to Fargate. So the migration from Fargate to Azure App Services is somehow straightforward. So it is easier than migrating from EKS to AKS, from Elastic Kubernetes Service to Azure Kubernetes Service. And actually Azure knows about that because they offer more and more easier to use services which use Kubernetes behind the scenes. But where I'm going with it, which is overestimated, the value of open source product in the cloud. Because instead of using Kafka, if I'm starting Greenfield, I could also use Kinesis. Done. And I'm way faster. I don't have to provision anything. I save a lot of time. I can use CDK for everything. The security is better. I don't have to patch anything. It just works. So what is highly underestimated is, the effort migrate between clouds regarding, tokens, security, networking, authorization, authentication, and even provisioning. So what many managers believe that you say, okay, or not even managers, we have a Terraform, then we have multi-cloud. So now we have a terminal, but the syntax is different to AWS and to Azure.
Can I say that I disagree a bit with you here? Okay, regarding the open source stuff, think about Postgre and MySQL, like how important they are to cloud providers, and they have no real solution to replace them. Google has Spanner. It's similar, but it's not the same. Okay, there are many other attempts to get the same thing, but developers like SQL. And there's no alternative in all these services that can match these functionalities that these services have. And they're trying really hard to provide us a managed service like Aurora that can do a lot of stuff. But if you just go one layer lower, it's MySQL, it's Postgre.
It's Postgres was replaced storage. But
you see that it's still like it's super important. At some point, when AWS introduced Aurora, it was the fastest growing service, and I would say it's still like the most important, one of the most important services, the backbones of the system.
How to put it? You remember OSGI?
Yeah,
we had the same discussion about OSGI. Not we, but I had with developers. I said I don't care OSGI. Because I use application servers, and for me it's good enough. I don't need to know OSGI modules. And they say, look, but OSGI is very important. It's an open source technology, and is used by application servers. And I told them, maybe, yeah, cool. They are using OSGI, but I don't care. I only would like to use the application server, not OSGI. I use Glassfish, and I never use OSGI features from Glassfish. I use Whitefly, but I didn't care about Whitefly modules in Whitefly. The same here. So the cloud providers can use whatever they like. As long, I'm happy with the API and I'm productive, I don't care. So this is maybe the difference. Yeah. So if Aurora would have, JDBC API with SQL and behind the scenes is Postgres or whatever, or even Oracle, I don't care. As long, the pricing is right, it's stable, and I don't have to patch it. So
we just need a HTTP API for a relational database is a core thing. If you want to look in the future, so. For the cloud service providers, one day, if they're smart enough, maybe they will replace the entire database in the backend. And I wouldn't. So if I don't notice it, I don't care. Maybe, but look, they still didn't manage to replace.
Yeah, because it's a huge effort. It's a huge effort, but it's a huge effort, and this is very important. From the how they do it. But you are talking from the cloud provider perspective. I'm talking from the developer perspective. Mm-hmm. So this is exactly You remember discussing with Java EE? I said I really like one dependency Java EE, and I'm done. I don't care what's inside. And the Java EE developers who did the server side, we have to have modular application server side. I don't care about your modularity. Give me one API, I'm happy. And this is a similar discussion here. And what I just saying, what I see is that the companies who are moving to cloud are afraid of the cloud and try to abstract everything in hope that you can switch the clouds easier. My observation is what they're abstracting from is not the actual problem. So if you abstract, for the database or whatever, we can manage this as developers. But they are completely depending on the infrastructure like security, networking, which actually takes more time to do right than than migrating something from ECS to Kubernetes or from ECS to Lambda.
I agree with that. The identity is the biggest lock-in.
Exactly. Exactly. And no one cares about that, right? So this is like I never heard in a meeting in a company, we have to be careful with identity. No, they say we have to run Kubernetes in order to be portable. It's like great. In Kubernetes even worse because you have you need the IAM roles and users for the setup of Kubernetes, and then you need the permissions inside the Kubernetes. So you have two problems now. And if you would use Fargate, way easier. Okay, cool. This was a little bit of discourse.
Just to say that I was like in the last couple of months, I had some kind of I have several deployments of some Kubernetes stuff.
This is why you had a busy summer. Mine was more relaxed because I tried
to customers said, Can you just go back one step and try to do this locally instead of Lambda? And I said, okay, let's try. And I was really shocked how things are fast. When you do that locally. I just forgot about that feeling, like how things can work on a dedicated server. So, cloud gives us a lot, but it can also take us some stuff. In terms of accessing databases, one of the things which is really important.
But wait a second. So what you said, you worked locally on your own servers, right?
Yeah. On my clients' on-prem installations, I use the same code in Quarkus, just packed in Dockers and deployed it into Kubernetes, and it was super fast.
Yeah, but if I had a good enough data center which fulfills all requirements, I would not go to the cloud.
Yeah, there's a lot of things. You go to your client's system, and then you say what you need, and they say sorry, but we don't have that version of Kubernetes.
Exactly.
And then you start suffering, and then it's there's a lot. It's not just it's easy to make the application, but all other stuff that are there to make an application like on a business level, like integration with Active Directories and other stuff. Yeah. Oh my God, it's just there's so much of that. It's I have a feeling that 70% of my applications is dealing about the rest of the stuff, which has nothing to do with the application. So when you're in the cloud, someone else is doing that for you, and all this small stuff, about scaling and other, it's already there. So that's why I'm suffering a bit, but and I really want to go to a managed solution in any for everything, but it's obviously not going to be easy in the future. And because you see, if you see the uncertainty, the people will say, okay, I want this locally. When people are optimistic, they will say, okay, I trust the cloud. I trust American companies. I trust Chinese companies. You see that the world is polarized, so you have to really be careful what's going on. Because someone can just disconnect your service. The companies are kind of So if you're just depending on one thing, you can be in a problem, and you can find a lot of examples. Like PayPal is not paying money to people who had just why? Who cares? It's an American company. Jurisdiction is kind of a super hard to understand. So these things are kind of can be really complicated. That's why it's good to think always just like you said, what would I need to run my application inside the on-prem system? But anyway, my preferred way of deploying applications is AWS cloud and serverless, as we talked, and as you mentioned at the beginning, serverless is the highest level of these managed services, but it brings us some new issues with the connectivity. That's like a proxy stuff and a number of connections and stuff like that. So about the crack. So one of the things that is
we are not supposed to know it, right? No.
No. Crack is like Java stuff.
Yeah, this is the open source Java stuff, OpenJDK, where you can preload.
Yeah. So the crack is coming. Okay, so it's a user space way to store and restore the user space. Okay, so for example, if you would run something if you start your application, you would usually during the initialization phase, you would connect to a database and keep that connection over, just because you would use all the resources on start to get that connection and everything ready. Like in past, I would usually set the minimum number of connections in connection pool, so they will automatically connect. So that's how you would do that. But look what Crack is doing now.
Crack stands for, I'm just on an OpenJDK. It is the coordinated restore at checkpoint.
Yes,
and
yes.
This is an OpenJDK project where they can very, very fast restore the state.
Yeah, but there's also like some technologies that in a Linux kernel that can restore that in user space, so you can have it easily. Okay, so I don't want to go too much deep, too deep in this. But the thing is, when it restores the snapshot, you don't have anything. It's empty. You just have your data in user space, but all connections will be erased. Okay, so it will help in terms of like all this Java stuff. It will help really to reduce the cold start. But then, when it started, you always have to go back and connect again. Okay, so connections cannot be persisted somewhere. So we will go back and to the state where we need to connect again. So what I tried in the last couple of months, I tried to remove all the proxies between our lambdas and the backend. I tried to make a solution where I will always open a connection, do stuff, and close it. Okay.
Okay. Good.
Oh God, it just worked super fast. I didn't really kind of notice any kind of super big problem because I'm using MySQL. Just to say that, I would say that if you're using Postgre without proxy, that wouldn't work. But Aurora with MySQL has a really high. It can accept a lot of connections, and it's super fast. So I don't really notice that kind of a lag anymore. So I was just thinking, okay, why would I? I should think more about that in a cloud way. You always start something, use it, and kill it. Start it, use it, and kill it. So that's the way to do this, do stuff. So if we would one day, we will probably have this HTTP3 client, and then the speed of the connectivity would be super fast. So we would connect to any kind of service in a millisecond, so we wouldn't notice that. So
but I think the problem with the connection is not necessarily HTTP3, rather than what the databases are doing. They are what they did is they had per connection a memory space.
Where that's one thing.
Compiled, the compiled select. This is why we need prepared statement. But over time, the prepared statement were global and not associated with the connection. So right now we can get actually better performance without prepared statements, or not better, good enough performance without preparing statements, and closing connections could work because the databases are optimizing better than 10 years ago.
But there's a lot of hops, When we talk about making a connection, it's not just about for example, do you use TLS to connect your backend service to a backend database?
Yes.
You see, adding TLS to the connection.
No, I don't like to, but I have to.
Yeah. You see, and then it adds extra time. Extra resources to get these things. So it's so we need protocols and which would help this, to avoid this kind of extra time to connect, and then so we can faster connect and disconnect. Okay, of course, if you're doing millions of small transactions in short time, it's a really different thing, But then maybe you need different strategy, like in terms of batching stuff or I don't know. Do you remember when do you use Oracle in any cases now? Did you ever use Java store procedures in Oracle?
Yeah, sure. I tried that. And by the way, you remember at the beginning, Oracle had a virtual machine. You know the name of the virtual machine?
Yeah.
What was it? Aurora.
I mean, really?
Yeah. If you search for Oracle Aurora, so this is what I experimented with. It was around 2002 maybe. So Oracle had an own Java virtual machine called Aurora, and you can run Java stored procedures on it. And what Oracle does right now is actually pretty cool. They are able to use GraalVM to run JavaScript in the database, so it's also nice.
Yeah, that's another step, But just where the code is, and can you provide parameters and everything, and then the code can be executed inside the database. Maybe you just need to change the strategy, But if we go back and look at what the cloud databases are now, it's we need to understand like what kind of a use case we are trying to solve. It's in most cases it's the same use case. You have a website where people can enter some data but then consume a lot. It's not that people are just like making a lot of stuff, writing a lot of stuff. It's always like a lot of reading stuff, blogs, all these strategies. So in terms of that, like relational databases and other and similar solutions, like they're not really like the most optimal way to deal with these things. You may save some metadata somewhere, but then when you use this data, you don't really need that. So you should just do it in a different way. So what AWS does for you is it does this kind of distribution for you. So if you have too much data in one database, it will split the database for you, and you wouldn't notice that.
Then we have to talk about this, because the main difference between you mentioned Aurora, and so if you mention Aurora, we should actually explain what it actually is. So for me, and you are actually the database specialist, but for me, what the main difference between Aurora and RDS is, if you have RDS, which Postgres, let's say, you have a Postgres and RDS, or MySQL, maybe the same, and Postgres and RDS means you have a primary database, and then you can have a replica, but the clustering works via the built-in Postgres protocols and capabilities. What Aurora did is, what Aurora did, they say we don't use the Postgres storage engine anymore, so we replace it completely with AWS proprietary technology. So there is no more replication, because if you write, the data is stored in 6 locations across several availability zones. So if you open another database, it has immediate access to the storage, which is genius if you think about this, right? Because this is
Think about replication that is 1 millisecond between 2 servers. You can
but from the conceptual perspective, it's like you have 2 database engines which are stateless, and they are accessing the same storage, which is very fast.
Yeah.
So this is Aurora.
Exactly. But of course, don't forget, these are only MySQL or Postgres. Nothing special, And if you have one page that is in memory on the second server, and the first server, on the master server, your main server, you do some changes, it has to invalidate that page. So it's not only communicated through the storage, it has to do some kind of invalidation. So it's tricky, but it's super fast. That's the good thing, And what they provided us is not just like the replication to 15 different read servers in the same region. It also provides super fast, I say really super fast, replication on a storage layer to another region, like from US to Europe, something. So you can have a really global solution with that you can easily switch. It's a couple of milliseconds on a global level. Come on, I mean, you cannot do that. There's no way to do that in Postgres. Or there's always something, on this. When you work on a higher layer of databases, you send the command to be executed on another server. Mm-hmm. So it's not changing data on the storage layer. So of course, I mean there are many ways to scale and fix stuff.
Scale is important, but for most of my clients, what we have a couple of Postgres instances. And it's not like we are global, it is still enterprise. It's not like we are Snapchat or Instagram. And what it's cool for is backups, right? Because
it's not just backups, it's called snapshots.
Snapshots and snapshots and backups, because or how to call it, disaster recovery. Because we can use another primary database, and that it is always distributed, and we can very quickly launch another instance, or it's already running but it's not used. It's just hot standby, but you can within a minute switch to the other one. So this is even more interesting for boring enterprise project than high scalability projects. So this is my observation. And what's also interesting is the global database. This is maybe what you said, right?
That's the multi-region replication. The backend of the global database is to have this global storage, But look, just one point I want to make before we end this, these great conversations with you, but because there's always end to it. One of the things that people forget about the cloud is that, as I said, you can say that the cloud is slower than your local machine. Of course, your local server, your local data center. But once you start scaling, and I mean, it's not like super high scaling. Like if at the end of the day, people start running reports and blah blah blah. So in a standard company, you will have you will see the pressure on the system. Okay, so the biggest difference between having it locally or in the cloud is that someone else does the partition of data. I mean, of some kind, like for you. If you're using DynamoDB, which is the greatest example of this, you will get this kind of this partitioning done for you before you do the query. So if it's a large partition, it will be split up. So the goal is not to have the fastest database on earth. The goal is to have consistent reads and writes to a database. So if I have 10 users, I will have 100 milliseconds for a request and response, maybe. If I have million users, I will also have, again, 100 milliseconds to get data and save data. Mm-hmm. And that's the biggest difference between what you can have with DynamoDB and your local relational databases. With the higher usage, they're going to be overloaded, and you will see that you will be affected by that pressure.
That's the interesting part is how they do it.
1 millisecond or 100. What do you choose? Stability is the most important, not like not always the speed.
The interesting part is there's no magic. So the question is how they do it with DynamoDB. And the answer is pretty smart. You already mentioned the proxy, so they are sharding across the partition key. So this is the first thing. But there's actually the DynamoDB paper where lots of databases are based on, because it was published, and React database and lots of Cassandra is also using the same idea. And now the other thing
just as a notion, DynamoDB paper is not exactly the DynamoDB product.
No,
just like it's
this is like
for readers, it can be kind of sometimes confusing. Okay.
Yeah, but the ideas, like the partitions, are still there, the quorum or whatever. The interesting part is what you said. The linear scalability is not like they have a crazy technology. The interesting part is if you use DynamoDB from day one at the same limits for every access. So you cannot read more, I think, than 1,000 lines. There is a limit how much you can read per kilobyte.
There's a lot of limits. They just put too much limits,
But this is good because you can never overload the service. If there are limits, they exactly know, one node can sustain that much load. If this is too much, you get another node. But if you are locally, you can easily overload your service, and this is why it doesn't scale linearly, because there is no way to replicate your database. And the Dynamo, or to distribute the database. And Dynamo is distributed by definition, and of course you can overload it. If you are just using partition keys, which are not good, which don't have the how to call it, cardinality, which the cardinality is very low.
But like even in that case, you will always get the same kind of response.
This is like
bad response. It will always be bad
for the listeners. If you would use one key, partition key, which is not really good, so it means it's with the same story like there's a hash map, and there are objects inside which return hash code 1. This is a similar problem. So the better the cardinality, the more partition keys you get, the better the sharding across DynamoDB are working. Otherwise, you get so-called hot partition, which is bad, or it is not bad. It's not that good for performance.
But it's consistent.
It's consistent. But this is the interesting observation. If you would like on-premise create a highly scalable solution, it's not about magic. It's about limits, I would say. So every of your services from day one, every API, you have to be able to throttle, deal with throttling, deal with timeouts, and this is the challenge. Not necessary, to buy SSDs and in-memory persistence.
There is in that sentence that you just said, there's a hidden thing, that says that in cloud now we try to we need to analyze like what are the exact usage patterns for what we need, and then we have to focus on what we need. Previously with SQL, I still use relational databases, but I'm just saying, like, if you do that with the SQL databases, well, you can do any kind of query, whatever you like. Okay, so some will be fast, some will be super bad, and you can influence other people making queries. Okay, so but in Dynamo and if you want to do something for the cloud, you should look at the usage patterns and then do some stuff for that patterns. That means sometimes that you have to duplicate data. So
Always.
if two persons need to look at the same data in two different ways, maybe you just have to prepare the response before they need it somewhere. So like if you are looking at your Facebook feed, maybe someone prepared the feed and wrote it into some JSON file before you even asked for it,
Yeah.
And then someone else is looking in a different way, the same thing. So you need to understand usage patterns and then pack data in a way that it will be used.
Exactly.
And that's the biggest difference, in terms of
Remarkable. So you as an old or young database professional saying this, because this costs me a lot of time, because if you use DynamoDB S3 or something similar NoSQL technologies, you organize the data across usage, how you would like to see the data, and not how the data is stored. And before that, we organize the data in optimal way in a database to save hardware resources, and there was a lots of joining and stuff to prepare the data to present it to the user, which was complex. Very good thing. And of course there are challenges how to keep it up to date. And also what I find right now in my current projects is you have also to think about for what you are optimizing. Are you optimizing for writing or reading? What should be faster?
Of course.
It is often very challenging to have a crazy fast, write and reads at the same time. So currently, for instance, we are thinking, okay, we switch our strategy from, slower writes, which can be asynchronous, and faster reads.
Yes.
But you cannot have both and consistent, right? Inconsistency.
Of course, there's no consistency
this is
anymore.
the cap theorem. But but this is actually, if you manage to do this, and what it actually means is forget what you know, like beginner's mind, and just write simple apps. This works better than expected.
The biggest problem is the perception of this consistency, But when you save something to hard disk, there can be a cache, that can be running on the battery, and you can have a feeling that the data is written to a database, to a storage.
You are a true hacker,
So at the end, it doesn't have to be like that. So in Aurora, the Postgre calls one API and says, please save this data.
Yeah.
And it saves it to like 6 different locations, but it's not actually saving it in that moment. It just says, oh, I acknowledge that I received this data and it will be safe. Mm-hmm. But it doesn't mean that it's on the hard disk in that exact second, So that means like you have to really trust all the layers below,
Yeah, but this is it's code about. It's code about trust. You have to. Yeah.
I mean, even in your local network, you have to think about what's behind the hard disk and stuff. And one last observation, maybe that's something that is really changing the way we deal with the data in the cloud is previously, if you wanted to do some kind of aggregations analysis, you had to do a lot of ETLs. You have some data and then you have to transform it so you can do queries. Okay, but what cloud providers allowed us in the last couple of years is that you can have queries directly on the data, which is stored in a CSV file or Parquet file or something that is row or columnar based. So you just put files, and then you organize views around this data, and then make queries against that data. So the storage, what we called previously storage, is not storage anymore. Like for example, in AWS, S3, it's not just a storage, it's a really smart storage. There's a technology called Aqua that does some smart things. For example, I can ask the storage layer, can you please make the average number in all CSV files in that column, and it can aggregate it on that server. And then it can call hundreds of servers at the same time and maybe do some aggregation of any kind. So it's on the storage layer that the change is happening now. So the storage is now intelligent. So you can just dispatch the request, and all these servers will just give you the answer. So you see what's going on. You don't need to do some super complicated ETL transformations all the time. You can just keep data somewhere and then aggregate it. And what is now happening, it's called elastic materialized views, whatever, glue materialized views of some kind. You can connect any kind of database, like DynamoDB, S3 storage, relational databases, blah blah blah, and then you say, okay, make me a view of everything, and then you make a query. And then the query happens in that particular moment, or if it's materialized, it can check for increments and then do the change. So you see, you can write data to a database that suits you. You know, you can do your transactional system can work with that database. But then
you know what it is? CQRS, command query.
Yeah, exactly.
This is exactly what this is built in CQRS. We write the data in this way, and we read from different. This is actually built in, which is really great. I was, at the AirHacks workshops. One of the question whether I consider CQRS. I say why I should do this. I mean, this is if you have the traditional premise database and you have JPA for everything, why would access something differently? But in the cloud, if it's already there, it's perfect. So as you said,
and it's easy. It's easy to.
I just can use it. But why I will? This is actually interesting. Also. You could even say that CQRS became, a cloud-native pattern because it makes absolute sense on the cloud. It makes less sense locally because you will have to implement this, right?
It's not about the cloud only. You can see the Bezium project. It's like the perfect example of things that are happening. Like
where I'm going,
people are moving data. People are moving data to a location or the storage or the engine that will provide them later better queries or better user access patterns for that data.
Because otherwise, and hopefully you agree. Otherwise, we'll talk for another hour. But if you are locally and you would like to install Debezium, you need to know the engine rights in Oracle. You need Golden Gate license, or if you use Logminer, something different. But you need skills to do it, and you need approval in production to do it. It will take time. Then you have Debezium, but you don't have Kafka. So you have to install Kafka and hook up with Debezium. You have to do this. So I would say it will take you, if you do it the first time, at least 1 week just to set it up.
But that's fun. Okay.
That's fun. But if you're in the cloud, you have DynamoDB with Kinesis streams. It means this is no different to create a topic. So, I mean, you can use it or not, but it's already there. So the difference for me is in the cloud, all these services and systems are already available. Locally, I will have to implement everything from scratch. In one point of time, it is too expensive and too complex.
Trust me, I wouldn't believe that if someone told me that like 10 years ago that I would connect to a binary log to a MySQL through Java and read stuff from it and do some like CDC stuff like by myself, I wouldn't believe that. I mean, I have some edge cases where it's like super useful, I see these skills. We cannot just forget them. It's easier, but then some new stuff comes always, and then you have to fix some new stuff, new problems, new cases, and then, well, if we forget about this open source stuff, like really, I mean, we can be stuck maybe we will slow the progress.
Forgetting, maybe it's different. You're building a product. I'm in projects. So if I'm asking what to do, I have to justify. Okay, my client, okay, we will install everything here, and you need these skills to do it. I could do it, but the other developers that also know to understand it, and I have to convince them to do it this way. Or in the cloud, you don't have to convince anyone because just configuration. I say this is the DynamoDB table. Write it to Kinesis. Done. Right. And by the way, we should meet next time and talk about Debezium because I use Debezium a lot, but not in the cloud.
Really? Excellent.
Yeah, I use Debezium for very specific use cases, which are great. What do I use? Debezium together with Kafka and Kafka Streams, and for truly microservice architectures, and also for cloud sync. And Debezium is the best technology ever if you have on-premise database.
Yeah, okay.
And but what I'm saying, if you go to the cloud, is completely different. So
of course there's an overhead in in all this technology that you have to learn about these days, but
and maintain them, patch them. This is the problem. Patch, the
do
entire life cycle is the problem.
Do you have a Raspberry Pi cluster at home?
No, because I have a real cluster.
I just built another one. Okay. It's running Kubernetes 1.25. So. That's the life of
this is why your vacations are busy, because if you're playing with Kubernetes, you have to write lots of YAML. I'm a Java guy, so I have lots of free time.
You see that there's always something new. You have to embrace everything, and then something new will come. If we just support our cloud providers, that's going to be maybe an end to us. Like open source community is really pushing cloud providers to next levels. They would stop probably developing, but like open source is just amazing. Whatever you think, the cloud providers are great. Open source brings always something new. Like I'm really impressed what Postgre community is doing. Like really always some new ideas, some new stuff. Maybe it's not super useful, but it's always something new. Like,
but I'm speaking not from my leisure perspective, rather than from business architect perspective. And in this
you just want to use stuff.
And what I would like to have in my commercial projects, a clear decision. There's a consequence. If we are going in the cloud, we should use the cloud. And if we are on premise, we should focus on open source, vendor neutral solutions. What I don't believe it, go to the cloud and don't use the cloud, just install a virtual machine and put all open source project on it.
That's crazy.
So this is I mean, no one will understand this. So
imagine using AWS without S3.
Yeah.
Just local hard disk. That's complete nonsense, That's
I see this in project, and they say they are cloud native, right? Yeah. So so this is what I'm talking about. So if you go to the cloud, I would always prefer manage proprietary. I say proprietary. I don't care about the standards services from the cloud. If I'm on premise, I would go, whatever I talked the last 20 years, just vendor neutral, JDBC, JPA, microprofile, whatever I have. I'm very happy with it. But what I don't like, the mix. If you have to care about the open source stuff and care about the cloud, so you have to care about both things. It cannot be cheaper. It cannot be more maintainable than an on-premise solution. This is what I'm talking about.
And don't forget, I had some serious trouble, a couple of times with the Aurora a couple of years ago, just because it's using actually the open source technology with all its bugs and all the issues, that are inside. So there are many layers to that decision. So you think you are using the proprietary system that provides you super secure and everything is fine. Don't worry, Adam, you'll sleep fine. But then someone committed something in the open source repository and it was acquired by AWS into some project and it just breaks,
Sure.
So there are many layers, from that top service that just provided for you, and you should never feel safe, Adam, in the cloud.
Of course not. I'm just. It should be, the strategy should be clear. I don't like some confusion that everything is, we could do this or that. No, we go this. This is the strategy. We have to validate it. We have to test it, and if it doesn't work, we can do something different. But let's be clear what we are heading for. Perfect. Exactly. It was fun. Where people can find you?
Great. I'm on Twitter, Goran Opacic, OPACIC, and you can just search for AWS Data Hero. That's one of the things that I'm really engaging with. If you are in Netherlands, maybe you can come to our AWS Community Day. We'll talk in like 15 days. We'll talk about Aurora Serverless V2. It's a whole new, it's an entirely new product for AWS, auto scaling on vertical scaling, and that's super great. And many meetups, stuff like that.
Cool, perfect. And next time we can talk about the Bezier more open source on this cloud.
Yeah, yes.
So then we can have no cloudless. What do we do without cloud? So this would be an interesting discussion.
Yeah. That many people asking me these questions these days. Mm-hmm. So I'm really worried. What did I invest in the last 10 years? I was just pushing to the cloud so much, and then now everyone is asking, oh, I don't know. Why are you so sure? So, well, I cannot sleep safe, also.
Perfect.
Great, Adam. Thanks.
See you next time.
Bye-bye.